As you can see, these are notes, and we're moving forward with our topic of relations, and we're going to add to that the word functions, which is really the bigger idea that we'll be talking about. So last time we just had to write a relation some different ways. Well, now we're going to identify if that relation is actually a function. So it's a pretty short definition. A function is a special type of relation in which each input has exactly one output. That's all you have to look for. And the second line just says what we already know. They can be represented in several different ways: ordered pairs, tables, mappings, and graphs. So, is the relation a function? So what you look for, look at the input numbers. Okay, the first number, the x number, the domain numbers. If they repeat, it is not a function, because that input 3 does not have exactly one output. It has more than one output. It has output of 5 and an output of 2. So this one is not a function. Okay, now when you look at the second example, look at the inputs. That's what you will start to look at. They're all different. That means every input has exactly one output. So this relation is a function. I already have written underneath it some information for you, and I'll again will make these notes available. So if there is an input that is repeated, it is not a function. Okay, so we're going to answer the same question now with a table. Is it a function? You do the exact same thing. It even says here, check to see if x repeats. We don't care if y repeats. Don't even look at the output to make this decision. You don't need it. That often causes problems. People see output numbers repeat. They could all be the same number. They could all be different. It doesn't matter. So I even have them blocked. Look at the input numbers. They are all different. That is a function. Very similar to looking at ordered pairs. Same over here. Ignore that. Look at the inputs. And you see 2 repeat. That means the input 2 has more than one output. That is not a function. You just have to know what to look for. It all depends on the input. Okay, moving down. We will do the same thing with a mapping now. Is it a function? Well, let's see. This input 4 has more than one output. Again, I don't care that 6 and 8 both share that output. That doesn't matter. You're counting. If a number has one arrow coming off it, it has one output. We don't care if it's the same. But look at 4. If there are 2 arrows coming off of an input, that is not a function, because that input has more than one output. Now see over here, you almost in a way, here I'll cover up the output. Notice how every input has one arrow coming off of it. That's a function. I don't care what happens after those arrows. That's a function. Okay, and I'll cover up the other one just to show you what I was trying to get across to you. If I cover up the output, again, we're not worried about it. Notice the 4 has 2 arrows coming off of it. Again, we don't care what happens after. Not a function. So I added a little bit to the bottom here, trying to show you that the output 4 has, or the input 4 has more than one output. Over here, that's okay if outputs repeat. So finally, we have to be able to tell if a graph is a function. Well, there's something called the vertical line test. And all you do is draw a vertical line. Oh, by the way, this is the x-axis. That's the y-axis. Sometimes it gets a little confusing looking at that. This is actually the graph, that V that's sideways. If a vertical line can go through the graph more than one time, it is not a function because that input has more than one output. If a vertical line can only ever go through that one time, it is a function. Sometimes this is a little hard to see. People struggle a little bit trying to see what I'm doing until they see it, then it seems easy. But I guess a lot of math is like that. So I try to summarize that. A vertical line can go through the graph more than once. That means it has more than one output. That makes it not a function. It failed the vertical line test. And over here, a vertical line can only go through the graph once. And finally, just a little bit of review at the end here. Well, not review, but from the front of the page. Tell whether it's a function. Again, ignore those outputs. You try this one. If you think that's a function, look at the inputs. They do not repeat. That is a function. Same. Cover up the output if that helps you. What do you notice? Function or not a function? What do you think? Well, 4 has 2 arrows. That means 4, the input, has more than one output. Not a function. Look at the graph. Do the vertical line test. If you draw vertical lines through these points, it only goes through each point one time. There are never 2 points on there that a vertical line goes through. That is a function. Okay, now just imagine there was a point right there. Okay, if I drew it. Then this would not be a function because a vertical line would go through more than one point. Okay, and 3 more, and then yes, this video will be over. You decide, try function or not a function, and I'll tell you what I think. Okay, well, it's just a horizontal line, and a vertical line can only go through that once. That is a function. This one, a vertical line can go through it more than once. See, once, twice. That makes that not a function. All right, and finally, if you think, well, a vertical line can only go through it once. Well, what about over here? A vertical line can go through it more than once. See there, there, and there. That makes it not a function. So the assignment is 2 pages, but again, very short answers. Do your best. Let me know if you have any questions.